So um, we're going to be debugging a C++ code that's supposed to um, do shading using a physically based rendering pipeline. Hopefully, I would be able to debug it this time. The last time it was didn't went so well. So hopefully this time I will be able to do something more interesting and have a decent outcome. Let's look at our source code. Normally, the code we have should work quite fine. It's the shader that's not working so well. So let's take a look at that. First, we get into building, make, install. Everything is good. Now we get into the bin, which contains the executables. The last time I made the silly mistake of launching PBR texture, whereas the compiled version is PBR out, not PBR texture out, but PBR out. So let's launch that. And as you can see, I have a fairly nice black cube here that I can't seem to find any way of debugging. I lost my light source for a second there. Let's see, I can take this down, up, take it down and up. So in this position, I was supposed to see at least textures. Well, this is not working apparently, and so I'll try to follow the tips given in the book of Folly. If you haven't heard, about it, I really recommend you guys to check that out. It's a very good book. I've used it a lot of times. Um, the debugging tips are also a nice gesture of them to include, because since they have a lot of experience on the subject, I assume they did a lot of debugging as well. So it's good to have that kind of suggestion at the side. Let me pass the reference of the book to the chat in a second. Basically, what they suggest is to reduce the case to its most basic state. It's difficult to imagine what that would be in a PBR pipeline. So here is the reference for all those who are interested. No, not this one. No, not this one. Let me remove that. Where is it? Not yes, this one. This one is the good one. This is a very good book. I suggest anyone who is interested in computer vision and computer graphics by any means, just take the book, read it, and it's quite complete. It treats a lot of subjects. Uh, so yes, they're not using OpenGL. They're using another API, but still they do make remarks about OpenGL from time to time as well. And it's the what? It's the 30 30 something chapter that talks about debugging. Let's see, contents. Yeah, they are using Windows Presentation Foundation package. It's a Microsoft based package, if I'm not mistaken. They are using C Sharp, which is quite relevant to computer graphics. Let me just search debug. They're treating debugging in 15th chapter and in 32, in the chapter 32. They suggest to reduce the case immediately to its most basic state. That's what I'm will try to do. Basically, I will create simpler shaders and pass them along to CPP code, and hopefully they would work. So I won't be touching the Vertex Shader. I will be mostly dealing with the Fragment Shader. Okay. So let's create a new Fragment Shader. Simple PBR1 frag. It should be more or less the same code, but the main function would differ. Same uniforms, same light position, light color, cost stuff, yes, normal, all that distribution functions as well. It's just that the main function would be different in the sense that we're going to simply ignore all this at first. I can either delete them or put comments around them. Both of them are possible. I'm thinking about deleting it, but I think putting comments is a better option. So let's comment out everything. Let's comment out everything. light direction, half direction. Okay. And let's format this. So now I have a half direction and a light direction. From this, I can calculate a fong-like model. I have the cos theta here. If I multiply cos theta with the diffuse reflection, I should be able to reproduce a fong-like model, which is most definitely not what we expect from PBR, but it's something. So let's get rid of this and simply they're just crowding my vision too much. I think I'm going to delete all of this stuff. I think I will do that. Yes, they're just crowding my vision so much, and I seem to get lost in all of this. Okay, so we have a relatively simpler main function now. I have the albedo map and the metallic map, light direction, and the half direction. The attenuation terms are defined here. Let's mix the albedo map and the metallic map. Now, even like before all this, let's see what we can obtain by visualizing the albedo map. Are we able to pass along the albedo map val? Albedo. Albedo. Okay. Let's now normally the albedo map contains the base color of the texture we are trying to visualize. So normally we should not have any problem visualizing at least the texture of the object in question. So basic color, simple PBR 1, surprise, and install. So this time let's see how PBR would function. Of course, it doesn't enjoy the fact that we are not it doesn't enjoy the fact that we are not using half of the stuff we put, but apparently we can't seem to visualize the picture so well, because the base color picture is something like the following. Let me see if I can find the picture to you guys. Display, or from the bin, display, media, not the shader, texture, rusted iron 2, base color PNG, and normally we should see something like this, as an object, our cube should be covered with this basically, but we are not seeing that. So apparently we're having some kind of problem passing along the texture, I think. So let's see what's not going so well. Our texture loading code is doing what? Texture load proc will be the map, metallic map. Now I almost always forget which one was doing what. The first format was the source of the texture, and the second format was what we want to show as, what we would consider the image as. I always forgot the meaning behind these two, so I'm going to check it out. I really enjoy using the site of Joey. If you haven't checked it out, for learning OpenGL, probably the best source would be this one. I used it extensively and I'm quite satisfied with the explanation. So I really recommend this site. There are other sites, there are really other good sites out there, but I use this one, and I can recommend it. It's quite good. So the first one is the target. The second one is the level, meaning that level of detail. The third one is the internal format. Meaning that how OpenGL should store the texture as. And the second format is the source type of the image. So I want to store the image as RGB almost all the time, so that I can um, I can fix the transparency levels uh, in the code myself. This is especially important when I'm mixing stuff. When we are mixing stuff. So let's see. Oh yes, the compiler errors. Oh yes, thank you. Without them, I feel so lonely, so left out. Okay, no, still not saying the good values. Still not saying the good ones. Hmm. The base color image should have how many channels? It should have 4 channels because it's a PNG image. Um, these are created here. Hmm. What's the problem with this thing? Linear. Let's skip these values. The source, if it has if it has 3 channels, it should be stored as RGB. If it has 4 channels, it should be stored as RGBA. Its source is RGBA. Let's yeah, compile. Now it's giving me something completely different. So it's the interpolation code that's making the thing a little weird. Okay, that's good. That's an advance. Um, Now we should arrange the interpolation code min-max filter thing. Type data. We should clamp to the edges. because when it interpolates, it's basically, yeah, when it interpolates, it's not a good way to handle filtering. Yeah, this is not the way to handle the. We can say repeat, clamp, clamp to the edge, maybe. Let's see what it would give. Here, wrap S with, because it's a quite a big image. That's why we should edge. Now let's see what it gives. 20 seconds for the eyes. And back. Didn't change a lot of stuff. Clamp to the edge didn't change a lot of stuff. So let's use this time. Let's change this time. Linear. Who knows? No change. No change. Let's keep these repeats. Very, 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 very interesting. If I say this is a RGB as well, it should really screw up this time. Which it did, thankfully. If I say this is a format as well, normally the fact that I'm calling formats on a 4-channeled image should not have any effect, because in the shader code I specifically want the RGB values and not the uh, not the not the alpha value. Very, very weird. But if we set the alpha value to 0 and then launch, nothing changes. That's reassuring. If I take the I see no pain. Yes. With the alpha value, now I should see something completely, hmm. This is interesting. Not so much. Not so much. Because it was in comments. Now, it really is interesting. Shader's going nuts on me. I am kinda frustrated with the overall experience, I gotta admit. So I'm making a lot of mistakes along the way. From the red value, I get weird stuff. Let's see what we have from the green channel. Almost the same thing. Uh, what if we do the following? This should work a little better, and it did not. Again, no. Nothing. Interesting. Let's see the metallic one. What's going to happen with that? There's a problem with albedo. There's a problem with albedo. Albedo map is the first location. Metallic is the second, and third normal. Fifth roughness. Now, in our CPP code, in its albedo, metallic, normal, and roughness. I mean, this should work fine. I am not sure why are we not, why is it not working? Uh, Texture 1 and texture 2. It's a 2D sampler. That's a given. Let's give 0 to this all the time. Maybe compiler errors? No. Nothing. While we're activating them, what's happening? Seems like it's working fine. GL active texture, bind texture. Activate the texture, bind the texture, then of course you bind the vertex array, but this is done while we are rendering the cube. Instead of let's change the API a little bit, and instead of binding, instead of making a triangle, rendering a triangle, let's render the cube. Though I don't think it would change a lot of stuff. Let's write a function that takes all of these and make a cube. Something like void render cube t. I don't know. So we have T1, T2, T1, T1. So T1, T2, T3, T4, T5, T6, 8, 9, 10. A lot. Let me see if I can find a better example with better coordinates. Let's see if we can find one. So we want to draw cubes. We want to draw cubes. Hopefully, I'll be using the coordinates given in Learn OpenGL for the vertices at least. This is the vertex data. But it doesn't have the normals. I should also have normals, you know? Basic lighting, materials, lighting maps. Okay. Let's use the vertices provided by the Learn OpenGL. Again, if you can buy the book and support Joy because it has a very nice book. So this is the vertex. This is the vertices. Has a lot of vertices. It's basically a position, normals, and texture coordinates, which is pretty nice. It's what we want. The render cube should also take the VO and VBO. Should take its own VEO and VBO, so we can activate them. We can create them before rendering, and we can bind necessary values when we want to render the cube. Okay. So let's find our buffers. VBO. Deoplete. Enable. And GL buffer data. GL array buffer. Size of VBO. And size of vertices with vertices as data, and we want it for static drawing. We bind the vertex array, VO. Then we start appointing we associate basically the layout we had given in the vertex shader and the vertices provided here. Enable vertex attribute array. Yeah, first vertex attribute pointer. I don't know why we call this one first. Because we can call the enable vertex attribute array as well, but kind of makes sense to specify the pointer first and enable it instead of enabling it then specifying the points. Let's write size t. F size is size of float times 8. F size and as a cast as a stride we give a 0, so it starts from the 0 position of the vertex array, and its stride value, so it repeats in every 8th element, and it starts from the 0th position. This is basically a pos of Vertex Shader. It's better to visualize the Vertex Shader as we are doing this along. Simple PBR Vertex Shader. So the first position is, in the first location there is a pos. We had done that. In the second position there's a normal. Now let's enable that as well. A normal. In the third position we have text core. Float as always. Not that. Void 6. If I'm not mistaken. Void float. Okay. This should be fine. When I'm like writing these type of stuff, since I know it, I feel so intelligent. but the problem is, um, when I'm writing stuff that really counts, like PBR and very difficult stuff. Not difficult, but a little more complicated stuff. I never really succeed really well. Then I feel so bad about it. Not about not being able to succeed, but feeling smart because doing simple stuff afterwards. Oh well, that's another thing. In here we simply draw draw the cube right away. Find vertex array VEO GL draw arrays GL triangle 0 to 36 triangle, since it has to draw a cube. Now let's see if we can do this. Let's see if we can make this work. Tangent cube shader. It's called tangent cube shader, but it doesn't do anything related. Doesn't really do anything about tangents or stuff like that. Let's generate our vertex array data, vertex array object. Set up some uniforms. We do that afterwards. Let's create our VEO. OpenGL VEO. Let's make it a little more fancy with VPO. Generate one CVO, and let's generate the buffer as well. We got the VBO now. And now we should render the cube. Cube T by passing along the CVO. CVBO. Doesn't require anything else. Hopefully. Yes, it does not. We can most definitely define all these outside of the rendering loop. Maybe it's better to define all these outside of the rendering loop. I don't think it would change so much since we're just testing stuff and not in production. Let's keep it this way to make everything in the same place. Okay, done like that. Render QP. We should declare it around here. VBO, not. And now, what? Where it ought to be I have forgot. Yeah. I forget to put the yeah. Forget to put the pointer. To be completely honest with you, I wouldn't call myself an expert on C++. I never seen someone who calls themselves an expert on C++ as well. But well, I'm not one either. Uh, I'm thinking about I'm thinking about really implementing stuff in Rust rather than in C++. Uh, but well, I haven't started that yet. Well, I get the queue. That's a good thing, but I still don't see anything happening um, in textures. Let's use something completely different, maybe another object, um, like stone diffuse 1, for example. It's also a PNG file. 20 seconds for the eyes. Don't forget to drink water, guys. It's very important. No energy drinks, nothing, no soda, pure water. Because I'm trying to lose weight as well. But apart from that, I don't really enjoy energy drinks as well. Okay, so there is clearly a problem here. Now, at least we can say that there is clearly a problem in loading a texture. Let's try this one. So I'm getting quite frustrated with this. So what I'm going to do is to delete more stuff, as you can imagine, to have maybe a light position and maybe a working example of Fong Shader. Then I'll try to develop that into a physically based shader by adding some stuff, most of the stuff we see here. I got the cube right, but I can't seem to do other stuff. So before further ado, let's delete a lot of stuff. By as a uniform, let me see what I can have. Frag. This is the Vertex Shader. This is the Fragment Shader. Let's forget that. Light intensity, who cares? Let's get the Diffuse Map. I and call it albedo map, because it's supposed to give us the base color of the object. Let's take all of these functions as well. Maybe not the spec color one. Let's structure val texture related. View direction, light direction. Specular color, who cares? Diffuse color, yes, we would like to have that. And the main function, the float computation surface normal, taken from the normal map, put it into good value. Oh, okay. Let's set up our main function. Let's put let's put everything like white first. Like simple white cube. Let's fix the PBR code to CPP code for this. So I don't need this, don't need this, don't need this. Thus, I do not need these babies. And while I'm at it, I don't need I don't need this, these, and what else do I not need? Shader, cube shader. I won't be using which ones? These. And and most of the stuff that are here. Model view projection, we're going to be using them in Vertex Shader. Do we use them? No, we don't. Like, we use them in the Vertex Shader, but not in the Fragment Shader. Let's see what we have. Can we see a white screen? Hopefully we should be able to see white screen. The code will compile and we shall see white screen. We see nothing, which is not good. What does it say? Undefined variable normal map. 38 line. So buy all this. Now it should work. A good old white cube. Good. Now let's try to set up a texture on this thing. Let's get the value for the texture. Like 3 albedo. Texture. I always forget, was it the coordinates first or... Yes, it's the coordinates comes afterward. And we take the RGB value. Now we see nothing. That's not good. Let's see what's happening in our code. Undefined variable normal map. Yes. We forgot. Oh yeah, of course. And we use albedo for this shader. Now I'm clearly doing something wrong here, because the textures do not appear in good positions. It's not like these code are related, but let's get rid of them. Let's inspire from the texture fragment shader. I was apparently having difficulties in this region as well while I'm debugging this thing. I assume it's really a problem with texture loading, not finding correctly the texture while we are drawing the cube. So let's add the activation of textures to here. The usual order is to bind the texture, bind the array map, and draw the texture. So we bind the texture, we bind the array map, and everything should work fine. Albedo map is already defined. Let's see what's going to happen this time. I don't have a lot of hopes. Was not declared in the scope. Let's declare the texture at above. I'm not satisfied with this. I'm not satisfied with this at all. Now I'm going to cheat by looking at my Funk shader code, if you can call that cheating. So, okay. Apparently I use the same strategy. 20 seconds for the eyes. And we're back. Okay. So we bind the texture. We turn the texture as well. I don't see, like, no difference. Any difference. I most probably copy pasted the code as well. Albedo map. Cube model, view matrix. These work really like fine. Let me see if my font code works. No point if yes, it works. It works. Font code works. That's nice. Hmm. Get the albedo map. Reload it here. New shader. Generate the such a fragile API. Active texture, bind texture, albedo map. Let's get rid of this as well. It's not like they're making something important. Plus, it's not failing to load the data. It just loads the data, but it's not. Um, like, what is the problem here? What is the problem here? It's not like it should make a difference, but yes, yes. Hmm. It's relatively simpler now. Code is much simpler now. Am I not enabling the color buffer? Is it something like that? Something as simple as that, maybe? I don't think it's related to this, to be completely honest with you. Yeah, once you delete the buffer, there's no way for that thing to survive after rendering, right? What is this thing? What is the problem here? What is the problem here? If I activate these babies inside my rendering code, then what? Then what? These are really like desperate modes. I see. Okay, so this is it. So this was the problem. No, this was not the problem. Like graphic API is simply like saying, "Bravo, you have not accomplished anything. Bravo, you failed again." With that cube appearing always the same way. Like, what is your problem? What is your problem? again, I have no idea why it's working. It works, why it's going to work. It didn't work, so yes. Then we load the shaders. Then we load the shaders, okay. Then we load the lamp shader. Then we deal with this. We don't need this. Light intensity. We don't need this as well. Fine texture. The rendering code is almost the same. I have no idea why is this thing not working. First one is working, and the second one is not working. It's it's very frustrating. What happened to Fong? What happened to Fong? Hopefully I didn't break it as well. Okay, Fong still works. Fong still works. That's nice. And the PBR code now, don't expect doesn't work at all. I really don't want to start this all over from scratch, but I can't see no other option than doing just that. So let's delete everything and let's start from a working Fong shader. Now both of these things must work now. Okay. Our PBR code now does exactly the same thing as Fong code. I will try to change what's happening here one step at a time. I'll do even a commit at the side for not losing this state. PBR reset to fung. Okay. No. Get tangent, bitangent, all that thing. We won't be using that. Simple PBR with texture. Hopefully this didn't break anything. Let's see if it did. Probably it did not. It's still the same thing. Good. Now we make a commit. Commit window title change. This is a very slow approach, I know, but it tends to work quite well. Now we change the shader to keep the name PBR Vertex Shader. Simple PBR1 Fragment Shader. And we let go of, we keep the diffuse map. Close this. Simple PBR1. Change the name to diffuse map. We lose the specular map. It's going to render the triangle in tangent space. We won't need we won't be using these anyway. So instead of using render triangle in tangent space, we're going to render them in normal space. And that means we're going to call render cube instead of render cube in tangent space. Render cube. Okay, so 20 seconds for the eyes, and I'll be coming back right away. So let's fix the vertex shader of the PBR to something more closer to the Fong one. Let's do something like media shaders, simple one vertex width, which is going to be equal to Fong vertex, except that it's not going to have all the fancy tangent stuff that's being appointed. Instead, it's going to out like, no, not these. Hue position, light position, ambient frag position. It's going to have a normal normal. Not even this. Well, maybe that. A normal is calculated with what? Yeah, I haven't thought about this, but I can use structs to hold these. Export is this, frag pause is that. We get rid of all this. We get all the stuff we wanted. You don't need view position and okay. And PBR one fragment should accept in normal, frag pause, normal, and text chord. So they complement each other now. Simple PBR code should now have, let's say for light intensity, 1.0. Don't need this. 1.0 again. You won't be using this anyway. Not yet, at least. Simple PBR 1 vertex shader. We won't be needing the specular one, the normal one. We just need the diffuse map. Not even a normal map. Not yet, at least. So tangent cube shader. Diffuse Shader init procedure. Don't need this, or these. We just need a diffuse map value. We don't need these as well. Not these as well. I'm trying to simplify the code as much as possible to build up upon it in an easier way. Yes, of course, compiler errors. Nice. Render tangent space, trying by all this. Indeed. Now let's see. Okay. Says that there is a syntax error at Vertex Shader. It really cries a lot, this thing, which is good. Oh, not this one, nor this one, not this one. Here. Let's try again, shall we? This is just ridiculous. So I haven't touched to the texture loading code. I haven't touched to anything. This is really frustrating. No. Yes. Please. Diffuse map. Uniform sampler. Frag color. I can't believe I can't show a simple texture. Everything is white. So it's getting texture locations wrong. Is that it? So let's like do a couple of stuff with this. I'll be the this is like the color. Let's get the surface normal as well, because you're already passing it along to say functions, surface normal, light direction, and diffuse color. And let's pass the diffuse color to fragment color as argument. And let's get the body of these functions. Get light direction, get diffuse color, uh, and we pass the uniform light position, surface normal code is this. So we set normal map as well. Set a normal map as well. Get diffuse color is this function. Which takes the light direction, normal, and outputs a color value with respect to the incoming light. Now these require two new uniforms, a normal map and a light position, which are not really hard to calculate, which are not hard to pass along. Let's do this. tone, normal PNG, normal map, normal map, normal map, and map path. Tangent, cube shader, C shader, C shader, shader. We set the projection matrix. Light position, light position, lamp model, light pos, light position. Now in the initialization, we also set the path for the normal map. If everything goes well, oh, what? Let's see. Now it should mostly work if we are lucky. The shading happens, but we don't have the good colors, but we do have the shading. We do have the shading. So we're not having the texture as we are supposed to. I at least can't find anything else as a problem, to be honest with you. Doesn't like the I have the light position and I have the textures in the correct order, but I don't think it really enjoys arrays. Render triangle. It seems like this is all good. No? Seems like it's good. I mean, you're passing along 20 seconds for the eyes again. Yes. Hmm. VEO, VBO, 3 VEO, 3 VBO. You're passing a point. No, the memory address. No. There are two triangles in a square. True. True. What if we say draw 6 vertices instead of 3? Nothing whatsoever, as usual. Nothing whatsoever. Is it? Like, what if, hear me out on this, what if I say draw elements, which is not a very smart thing to do, but desperate measures call for desperate moves, I guess. And if I pass along some index value to but I haven't created an EBO, and that's a problem. And that's the problem. I just have an yeah, I just have a VBO, not an EBO. I'm also like, so this is not the way. This is the way. Why? Do these textures do not exist or something like that? Can it be something stupid as that, maybe? No, they do exist. What if I use another picture? Container, famous one. Normally I have seen this code working. These textures as well. I am not seeing something very stupid. And what it is. What's that? What's that? What's that? You have to normalize the cost data as well. No, no, they're already normalized, so we don't have to. This thing is hmm. So we bind the texture, then use the shader. Can it be this? Normal map. But if we don't manipulate the buffers and all that. Just unbind the vertex array, not delete all the stuff. Nothing, of course, changes. During the initialization phase, we pass to buffer data, not a pointer, but the objects. I don't think this is the problem. Again, the same thing, same result, no change. I'm not touching to the texture loading code on purpose because it's supposed to be good. I mean, you've seen it work. You've seen it working, so I don't want to touch it. Let's get rid of this as well. We generate a texture. If there is the data, define the texture. I can, just for the fun of doing something, I can change this to a switch statement and feel like I've done something with my life. But I don't think that would solve the issues I'm having right now. This is not the issue, and I know it. Diffuse Map. 20 seconds for the eyes again. Take texture, we bind it to the activate the texture, bind the texture, bind the vertex array, then and draw the whole thing. That's that is supposed to be correct. Here maybe might be this, maybe. Ah, nice. We have the texture. That's such a rewarding feeling. That's nice. That's just nice. That's yes. 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 Now I can like I wanna play around with this thing. Just because I have them. Okay. Let's commit that thing. Have the texture and normal. Now let's add other stuff little by little. We have stone diffuse. Let's change that to rusted iron base color. Was it called base color? Rusted iron normal. And let's panic. Yep, we have indeed working. Not so fancy as in the stone version. Let me find if I can find free PBR materials are so hard to find. So free PBR, old Stonewall. I use the search engine DuckDuckGo. I suggest it to anyone who's using it. Industrial, narrow brick, concrete, cloth fabric, ground, metals, no. Path, road, rock, stone, yes, please. Rock, stone. Flashy granite layer cliff. Let's see. Layered cliff, the L. I don't know what the L stands for, but we'll see. Okay, so it seems like it has all of the goodies we would want from a PBR perspective. Um, so let's extract them to a proper location. And now we have layered cliff, normal, roughness, albedo, like all the goodies we would require from a PBR point of view. Let's add layered cliff, layered cliff. Let me just copy paste this thing to source code to have the completion available. Up. And I really enjoy using Vim for text editing. I think it's like the best text editing editor out there. For like IDE related stuff, it's not really optimal. Maybe might not be the optimal thing. But from text editing perspective, I think it's pretty nice. Fix the same old pointer errors. And yes, this is a little nicer approach. I mean, I have no idea what's happening here, what kind of texture it really is, but at least it responds to change of light, and that's what's important for my use case. Okay, it responds quite nicely. Alright, now We have the albedo, we have the normal. Normally we would also need an AO map, the metallic map, and the roughness and all that for a normal PBR pipeline. Right. So let's start to slowly build upon what we have. At p-value. So a simple PBR pipeline would require us to implement a normal distribution function for aligning microfacets, and also a related lambda function for a bunch of other stuff. I'll be coming right away. I just want to say I'm really happy to be able to obtain that visual uh, because, as Descartes once said, if you're in a forest, if you're in a forest in complete darkness, you just need to take a path and walk. I had no idea how to deal with that bug, but well, now we have a visual, so we can slowly build upon it. Okay. Before we get into like very fancy Fresnel functions and stuff like that, let's add like very basic stuff to our main function. For this, we need frag position and view position. View position would come as a uniform. And right away, we add that to CPP in order to not fail a lot of times. We have the view position here. All right. So we obtain the view direction, get the albedo map. So let's start by calling stuff with their proper names. Diffuse map changes to albedo map. We change right away CPP code to correspond to it. Now that I'm basically a paranoid about not breaking stuff, let's see if everything works for now. Says there's a problem. Now I can panic. Okay. Wants me to change. Now let's try once again. It worked, but it says it can't find a place for view position, which is completely understandable because we were not using it. View pos uniform video map name. All right. Let's get the metallic texture. So we need to have a metallic map now as a uniform. Let's make sure that the code corresponding to it works. Okay. Metallic map should now be activated in the main function. Let's see if we break anything. Seems like we can visualize stuff. Okay. It says we're not using the metallic map yet, which is true. But aside from that, seems like it's fine. Okay. Now we get the AO map. We get the AO map. So we do the exact same thing. AO map. We get back to our CPP code. CPP code and select AO map path A AO PNG AO PNG and select to AO. We pass it to shader initialization procedure AO map as earth. We activate the texture. And hopefully we didn't break anything along the way. Let's see if that thing works. Yes, that thing still works. So let's say map uniform added. Good. for each light source. We have a single light source, so we don't need to do a loop here. Get the light direction, get the half direction, did we calculated the view direction? No. Yes, we did. We have the view direction and we have the light direction. We calculate the half direction. Well, since we're doing this for each light source, we should calculate them for each light direction. Half direction, I use the attenuation term. Reference at 0 for Fresnel. Let's see. Get cos theta. Now surface normal is independent of light source, so we can put it here. Get cos theta is a function I'm also using the PBR book of Farr and Jacob. I also recommend that. It's a pretty neat book. Plus, it has a site online. Almost all the material are free. Plus, there is the GitHub repository as well. Now I'm passing the link in the stream. Here we go. Hopefully, maybe someday, any day, nowadays, please. This is the book site of the book. It contains anything and everything with respect to physically based rendering. And this function comes from there. Now, I also add another function called get positive cos theta using exactly the same parameters, except that I output this instead of regular cos theta. Normal in lighter. Now we can use both if we want to. We can test both if you want to. Um, Now the frag color, as we know it, at least should be cos theta times the ref at 0 thing. Let's see if we can visualize this. We set all of the uniforms, light post, view post. We shouldn't have any problems with this code. And just went haywire. Okay. That's normal. That's normal. Let's try that again. Completely black cube. OMap cannot be found, you say, meaning that we haven't used it. Okay. And what if we say get positive cos theta? It wasn't the cos theta that was problematic. I think it's the mix that's creating a problem. Let's see the definition of mix, GLSL. Um, so Let's look at the physically based from theory, physically based rendering book, shades, no. Sampling, reflection models, microfacets, microfacets. Uh, okay. Distribution functions. All right. That's nice to have. But what do we do with albedo maps and all the related material? Let's see. We use the first component of these values. What would we have? Hmm. It's not very. It's not very satisfying. Let's take albedo. Let's write some code for taking albedo maps. Something like vec3 get albedo. Vec3 albedo. This is from OpenGL. Learn OpenGL. I'm going to use their version of taking the albedo map. I'm also looking for PBR book version. Uh, Now, the problem with this thing is I see no way of working with albedo maps. So how am I supposed to load my texture? Texture coordinate, image texture, base functions, okay. Fourier transforms and stuff like that. Photon mapping, all the cool things I can see. I can see this is like, these are all good stuff, but okay, let's lose the OpenGL version for learn OpenGL version for now, and I'll see if I can find a more mathematically solid version uh, afterwards. This is, we're doing this, cool, for what? Albedo. Why? This question is very important. Like, you have to always ask why. I was once doing a Twitch stream, and one of the viewers asked me if they need to understand math to do these kind of stuff, and I said, well, it helps. Like, it really helps, having a little bit of math at the side. Okay. So we are mixing albedo. We're mixing albedo with Fresnel term. In terms of metallic, and 20 seconds for the eyes. Okay. Now, opa. Okay. Hmm. And what was the here? Yeah. Interesting. I'm seeing the exact same function in Learn OpenGL. The shader, the shader, the shader. Oh, the shader. Hmm. Yes. I have to check the actual source code to find a good solution. No value whatsoever. All black. All black. Whatever is happening here doesn't seem like it's a good call. Let's let's output directly the albedo thing, or equals theta times albedo thing. This should be more or less the fun version of our code. It already looks better. Wow, look at this detail. Okay, nice. Where is my light? Where is my light? 2D light. Thank you. Okay. So the problematic line is indeed this one. Just for the sake of curiosity, what if I mix metallic map with albedo using a coefficient like this? I don't know if it works or not. And so it's now a little less sensitive to light. It seems. Hmm. Okay. Now, let us start by adding a normal distribution function. First, maybe Fresnel. Of course, we need a function to calculate this. Okay, let's see. Um, the final result would be light out. The Fresnel term would be the final result would be composed of the Fresnel multiplied by the geometric distribution multiplied by the normal distribution, and uh, this, all of this for composing the specular term, by the way. Uh, the Lambertian term is simply good old cos theta with diffuse color. Okay. Let's define so we have a Fresnel term. Let's add also some normal distribution functions like traditional Beckman-Spitzino distribution. This goes here. The lambda for Fragment Spitzino distribution. The geometry function, which takes the output of the lambda. We already have the Fresnel function, so with this we can have the coefficients of the Cook-Torrance model, which is one of the basic microfacet models out there. So let's add the definitions of these functions as well. Yes, normal is traditional. Okay. Okay. It cos caret theta. It depends on two functions that we have not defined yet, which is cos square theta, and that's here. Basically, cos square multiplied by cos square. Shouldn't be too difficult. Let's add this to our utility section. And what and then up and ton square, which depends on tan theta, which depends on sin theta. Okay, which depends on sin square theta. So we basically need all of these stuff. Let's take their definitions as well. Okay. All right. So can I compute? Yes, normal, distribution, traditional, all that. 20 seconds for the eyes again. It's been 3 hours and I'm still debugging this thing. I'm not surprised though. Uh, so and roughness. Roughness is we have a roughness map as well. So let's load that. Let's call this row map. And let's see if our shader would compile this time. Yes. At least the error we saw were kind of reasonable. And here we should pass a single channel. Okay. Well, the shader compiles. That's a good thing. We're having a black cube as output again. Like 20 seconds for the eyes. I'm coming back right away. Chocolates don't help when you're trying to lose weight. Thank you. So I have the normal value. I need to have the geometry value now. And for that, I think I already written this. Yeah. And here we go. So we need the function called roughness to alpha. Let's add that to our utility functions and to our descriptions. This is these are all functions that I've written myself, but well, using sources, of course. Um, but since I tried to apply all of them at the same time, they failed miserably. EO. So hopefully this time I would do a better job of anti-substrate. No, we don't want that yet. I'll do a better job of having a reasonable output that shows at least something. So we calculate the lambda in and lambda out. Let's apply these functions right away to see what we have. So we have the dn, dn, dn. We have the lambda array, which helps us to get lambda in, lambda out, and we calculate the GD, which is the geometry distribution function. Now we have D, Fresnel, and G. So we can calculate the first term. Surface normal. In direction and out direction. Second term. Out. Basically, the rendering equation has two parts. The reflectance equation, has two parts. The Lambertian part and the specular part. Lambertian part is good old, like cos theta times the color thing. And the specular part, it is a little more complicated because it has to account for the alignment of the microfacets of the material. These are all good talk, but I'm not sure if we would be able to. Yes, of course we have problems again. As normal, narrowing of type, radiance. Start with here. Rough R. Radiance. Let's define radiance. Let's define it as 1. Now let's see. 20 seconds for the eyes. Up. And S normal. What is S normal? Surface normal. I thought I dealt with that. And weird. We have weird lightning. But we have something. That's what I don't usually get. So we mix. Okay. For taking the normal map, so I change the surface normal function to something else. Again, I will be using the OpenGL version of the function. This is what we used to do, which is not so bad at all. We're going to keep doing this because it's jolly. -1. Then we're going to use a dfdx function, surface normal, as we see here. Which would in turn use the normal coordinates incoming. This is fragpost, this is fragpost. Hopefully we didn't break too much here. Specular lights are on haywire. Okay. Let's first of all let's save this. Roughness added. Yes, normal distribution. Done. Buggy. But works. What was that? Ah, I okay. Okay. Now for the Fresnel term. Ref at 0, albedo, and metallic. These are all nice. Surface normal. This is with respect to viewing direction. So the Fresnel function, the argument of Fresnel function is not good. It should take a cos theta, that is this takes the cos theta as its argument. Yes, yes, indeed, indeed, indeed. That is the half direction between the viewer, uh, half direction, the cosinus of half direction and the viewer. Half direction, view direction. Now let's see. Okay. We say get positive cos theta, for example. What does it change? Looks somehow a little better. I think still we are lacking the problem of AO maps. Let's add some ambient color. Now that we have an albedo, we can get ambient color. Let's say that it is 0.2 times AO times albedo, maybe. And let's maybe add that to our light source at the end. LO at the end. Well, again, it looks kind of better, but these no, this is not what I would like to have. Let's maybe calculate um, saying the friend at here. Say get cos theta as usual. Let's use positive cos thetas here. Maybe it will change something, you know. I mean, it's happening. It's more or less working, but it's not what I would expect. That's the thing. Let's let's add some tone correction. Yok, zaten bu 4 Mayıs'ta falan yayınlanacak. On beş dakika ara vereceğim. Bitireceğim. This is all for gamma correction and related stuff. I don't think this is the problem, by the way. I honestly don't think that this is the problem, but never hurts. Hmm. It worked quite well. Nice. Nice. I was wrong. Okay. It seems like our PBR like function is working now. Okay. Speculars are not cool. Speculars are not cool. Um, Speculars are not cool, but the colors are nice. So it's the yeah, speculars are not cool. But oh, look at this. Oh, such a sight. Such. Look at all these shadows. Oh, yes. Look. This is pretty cool. Well, I will stop now because um, I kind of attained my goal here. That was to debug my PBR shader. It still has some small problems um, with respect to. Oh, you can't see that, or can you? Let's see. You see the results here. Fortunately, you haven't seen the. Look at this detail. Just take a look. Don't look at the specular thing. Let me deal with that. But look at this shadow. Wow. Isn't that cool? I mean, yes. Yes. Just those speculars are haunting me. I can see the mountains. I can see them all. Speculars are not working so well, but I'll have to deal with that. I think they're related to either my normal distribution functions um, or uh, they might be related to the ambient term or my kind of amateurish use of AO maps. But that shouldn't take too much time to debug. This was my attempt to debug the PBR shader, and I'm quite satisfied with the result. Hope to see you again, people, or not, but I do hope to see you again, maybe. Thanks for watching, and ciao ciao.